Okay, and last class we started working with these things called polynomials. And we talked about polynomials, Jolene, right? Okay, and do you need a copy of this? Yes. Yeah. All right. And polynomials are just things that have different variables and they're added together, like 2x plus 1 or x squared. Those things are polynomials. We talked about how to combine them together, like adding or subtracting or multiplying. Multiplying was cool because when we multiply two polynomials, we kind of get an expansion. So we kind of expand that polynomial. But then we started talking about these, the situation where we're given a big polynomial and we want to condense it. So we want to have two multiplied polynomials instead of just one big string. And we call this factoring. We talked about one factoring technique that we used called grouping. Remember, grouping was when we had four terms, so four things being added together, and two pairs of terms would share something. Then we kind of talked about how we could divide the polynomial in the middle, factor out the first half, factor out the second half. And once we had things that matched, we could kind of combine the first two coefficients over here and then put the matching one to the right of it. So that's kind of how we factored by grouping. Now, unfortunately, most of the times we aren't going to be given polynomials with four terms. We actually mostly look at polynomials with three terms, and we call these quadratic expressions. Anyone know what the word quadratic means? Oh, okay, so when we graph them, it looks like a parabola, good. Okay, and what do the equations look like with quadratics? I think you're talking about the quadratic formula, which is good, but I'm kind of talking about what the formulas look like. What's the highest power? 2, good, right? So quadratic expressions are where the highest power is always going to be 2, so x squared. So an example of a quadratic would be x squared plus 2x. Okay, so when the highest power is 2, we have a quadratic expression. Just thinking about this, quad means 4, right? So why is a quadratic expression a degree 2 polynomial? Anyone know? Yes.
Because when you distribute or FOIL everything out,
That's actually kind of smart. I didn't think about that. The way I kind of think about it, but that's pretty good. The way I think of it is we have an x square, right? Square, how many sides does it have? 4, right? And that's essentially what it is, because when we factor it, you can use the box method. But nice answer there. That's why it's called a quadratic, not a duadic. Okay, so let's talk about how we factor these. I know a lot of you are good at factoring this in your head. If you can do it in your head, totally good. But I'm going to give you a little systematic way to do this in case you ever get stuck. Because sometimes things get a little too crazy and then we can't do it. We had x squared plus 5x plus 6. This is a simple quadratic because there's no term up front. What is that term technically? What's the coefficient of x squared? 1, right? This is technically, oh gosh, this is technically 1x squared, okay? When we're dealing with something that doesn't have something up front, we're going to call that a simple quadratic. These are really easy. We just find two numbers and stick them in our factoring. Okay, we find two numbers that add up to b, multiply to give c. Let me do example 6 real quick. Now, let's see. We've got a b and a c. What is b here? B is the middle number. Oh, Jolene. 1, but there's actually something else attached to it. Let me. I don't think I went over this real quick. So let me just show you. I didn't go over this very good. Let's see. We want to factor x squared plus bx. B is the middle number, right? And c is the n number that's not attached to x. B is the middle one, C is the last one. So taking a look at example 6 again, what's B? Zach? -1, good. Right, the middle number is -1. If you don't see that, there's kind of a 1 hidden here. Okay. Any questions on how I got B? Oh, yeah. Oh, are you talking about to find the numbers, you need to find something that multiply like the first term times the last term? I think they are adding to get B. Let's see. Oh, I'm sorry. I wrote something down wrong. I'm so sorry. Oh my goodness. I was not paying attention. Okay, we want to, oh no. I think I did okay, right? Was I not paying attention? I was not paying attention. I'm so sorry. I'm very sorry, guys. It's a little too early in the morning. I'm very sorry. Okay, okay, let's do this. We're gonna scratch this. I'm gonna cheat in my recording. I'm gonna take this out. Okay. Okay, let's take a step back. I'm very sorry, I wasn't paying attention. Yeah, or scratch it out. We'll redo it on the bottom. Oh my goodness. All right, here we go again. Very sorry. Okay. Let's just take a look at this. We want things to add to something and we want to multiply to give something. Okay. We want things to add to the middle term. So we actually want things to add to 5. And then we want to multiply to give the last term, 6. I'm very sorry about that. I was not paying attention. I was just going with the flow here. Okay, what two numbers add to 5 and multiply to 6? 2 and 3, good. Okay, when we factor out quadratics that look like this, where the first term is 1, all we have to do is do this. Stick the numbers right in the factorization. Okay. Thank you guys for catching that mistake. Wow. Are we all good? Okay, let's do the next one. We've got B -1 and we've got C, which is -6, right? We want to add to the middle. So we want to add to -1 and we want to multiply to -6. Can you give me two numbers that do this? -3 and +2. Okay. Why did you make the 3 negative and the 2 positive? Yeah, like if we want to multiply to -6, one of them's got to be negative. And since we want to add to a negative number, we should get the bigger number to be negative, right? Okay, so that's why we made one negative and one positive. When we factor this out, we get x -3 and x +2. Okay. Any questions? All right. How do I know that I'm right? Yes. Awesome. So let me kind of expand what you said here. If I wasn't sure if I was right, which I guess I'm never sure right now, I can always just multiply the two together by what we did on the first page, right? So we can always do x times x is x squared, x times 2 is 2x, -3 times x is -3x, and -3 times 2 is -6. Okay, combine the middle two terms, gives us x squared minus x minus 6, which is what we start with. So we can always go back to this if we're ever unsure if we got the right answer. Okay. Any questions on example 6? All right, if you haven't already given example 6.5 and 6.75 a shot, I encourage you to do that now. And I'll be around to check to see if your answers are on the right track. All right, why don't we come up to the front here? We've got, did I get Robert to write up 6.5? Do you kind of want to take us through your steps here?
So I guess I just broke down savings, found this, those two components.
Mhm.
I think obviously the negative numbers, and then second two negative numbers to create a positive last.
Mhm. Yeah, so you even like checked your work to make sure that you have the right one. Oh, so you're saying if you found two numbers that were positive, would you write like plus in the final answer, right? Yeah. Yeah, so over here, we got a negative and we got a positive. The positive one ended up being a plus. Was that your question? Okay, awesome. Okay, nice job, Robert, on that one. Anna, do you want to take us through 6.75?
So this could have one of these.
Mhm. Yeah, sounds good. You got -9 and 2, right? Perfect. I did get a question as I was walking around. One thing, if you're ever confused, like which numbers to even look at, because you have to find numbers that add to this number, multiply to this number, where I would start is looking at the factors of the last number. Okay, it's a lot easier to find two numbers that multiply to something than two numbers that add to something. So there's actually an infinite amount of numbers that add to a specific number, right? So I would always start, for example, with 6.5. I would start with finding two numbers that multiply to give 12, because there's only like what, 1, 12, 2, 6, and 3 and 4. Then you're only left with 3 pairs to kind of figure out what adds to -7, instead of looking for two numbers that add to -7. That would take a lot of time. Okay. Any questions on factoring simple quadratics? Okay. Let's talk about the funky quadratics. So funky quadratics, what I basically think they are things that have something that isn't 1 in front of the x squared. This method actually does work if there's a 1, but the other way is faster. Okay, so we have ax plus bx, or ax squared plus bx plus c. For example, 2x squared plus 3x plus 4. Okay, that's an example of something I would call funky because there's something in front of the x squared. Okay. When we try to factor these sort of quadratics, we still want to find a number, two numbers that add up to the middle term. Okay, we want to find two numbers that do that. But instead of finding two numbers that multiply to the last term, we're actually looking for two numbers that multiply to a times c. So the first number times the last number, that's what we're looking out for, okay? Once we find these two numbers, we're gonna do something weird, and then we're gonna factor by grouping, okay? I know that sounds weird. Let's do an example and see how that kind of turns out for us. Okay. We want to factor 4k squared minus 11k plus 6. So we need two numbers that add to the middle number, so 11, right? What are we multiplying to? 4 times 6, which is 24, right? So we want two numbers that add to -11, multiply to 24. Okay, are the numbers both going to be negative, positive, one negative, one positive? They're both going to be negative because they have to multiply to something positive and add to something negative, okay? Okay, so taking my advice, let's start with 24 and see what things multiply to give that. Okay, we got 1 and 24, and that doesn't add to -11, right? We've got -2 and -12. That doesn't add to -11 either, right? Let's see what else we have. I'm not very good at doing mental math in my head. Any other ideas? Robert? -8 and -3, right? 8, 9, 10, 11. Add to -11, multiply to 24. So this is the pair that we are looking for. Any questions on how I got those two numbers? Okay. Now we're not going to do the same thing we did with the regular or the simple quadratics. We're going to do something weird. And I know some of you can do this in your head, and if that's totally fine, if you can do that. I'm going to take our quadratic, 4k squared minus 11k plus 6, and I'm actually going to split up that -11k into two parts, -8k minus 3k. Okay. So what I've actually done is I've taken this middle term, -11k, and I've broken it up into two pieces. Add them together, you can get back to negative. Okay. Now we have a polynomial. It has 4 terms. What can we do with this polynomial? Factor by, starts with the G. Grouping, good, okay. So what we can do is we can separate this in half, okay. What does 4k squared and -8k have in common? There's a 2, but there's something even bigger. 4, and they also have a k, right? Okay, if I take 4k squared, take away 4k, what am I left with? Okay, good. -8k, take away 4k, what am I left with? Not 4. I think a 2. The k goes away because we're taking away a k, so this is just -2. All right. On the right-hand side, what does -3k and 6 have in common? 2, but make it negative. Why are we making it negative? Because the goal is to make k minus 2 over here, right? And if we wanted to make it match, oh, well, oh, I'm sorry, a 3. This is way too early for me. I am so sorry. I'm making a lot of mistakes today. Oh, okay. Okay, yes. -3k, take away -3, what are we left with? Okay, good. And 6 take away -3 is 2, but make it negative. Good. Okay. So factoring by grouping, the reason I took out this -3 is because I wanted the k minus 2's to match, because if they don't match, we can't actually do the grouping at the end. Okay. So my final factors are, well, what are they? Not k minus 2 squared, just k minus 2, right? And then what's the other one? 4k minus 3. Perfect. All right, you're on the right track. So this is my factor. So I basically did a bunch of work to find two numbers to be able to split up that middle term. Then I factored by group. Before we go on to the next one, I have a little question, okay? I subtracted -8k minus 3k. Did the order matter here? Okay, so what I want to do is, you don't have to write this down, but I'm going to do an example, the same example, where I subtract the 3 off first and then the 8k, and let's just see what happens, okay? So let's do 4k squared minus 3k minus 8k plus 6. So I'm just splitting it up in a different order, okay? I just want to kind of make you see what happens here, okay? Factoring by grouping again, we've got, oh gosh, I meant to do that in pen. Okay, 4k squared, -3k, what do they have in common? K, good. And I won't drudge you through this, but if I take away a k from 4k squared, that gives me 4k. Take away a k from -3k, I'm left with -3, right? Okay, what do -8k and 6 have in common? negative, I think it's a 2, right? Perfect. Take away -2 from -8k, that gives me 4k minus 3. Okay, so when I piece these together, I'm left with k minus 2, 4k minus 3. So I got the same answer. Do you see what happened here? It basically gave you the two same factors, but like separated in a different way, right? So it doesn't matter which one you subtract off first or second, you're still going to get the same answer. It's just going to come about a different way. Okay. Any questions on example 7? Nice. Example 8 is very similar to example 7. So I'm going to give you a few moments to work on this, and I will be around to take a look at your answers. Okay. All right, Riley wrote up her answer, right? Do you kind of want to take us through this one?
So we're supposed to add to get b, which in this case would be -17, and you multiply to get a times c, which 6 times 5 equals 30.
Mhm.
And in order to get to -17, the two factors of 30 would be -15 and -2.
Mhm.
So then you grade out 6w squared minus 15w minus 2w plus 5.
Mhm.
And then I split them down the middle. And then you can factor out 3w to get 2w plus 5. And then you factor out a -1 to get 2w minus 5.
Mhm.
The answer will be 3w minus 1 and 2w minus 5.
Perfect. Nice job. Any questions on example 8? Nice. Do we feel confident? Oh, yeah. So how did we get which step? The numbers in the parentheses. So like from here to here, right? Yeah. Okay. I think okay. So we're gonna have two repeated.
Actually,
Things,
realize
right?
I wrote a +, negative. That's supposed to be
Oh.
2w minus 5. That's fine.
Oh, okay. That's fine. Let me just change that real quick. I wasn't paying attention, as we have learned. Amy does not pay attention during 8 a.m.s, but all right, nice catch there. From here to here, we're gonna have two matching terms, right? This becomes one of our factors. The other factor is combining the coefficients on those two matching terms. So we have 3w minus 1.
So how did you do
The 3w minus 1 or the 2w minus 5? This was the repeated factor, right? So the repeated one becomes one of our factors. The coefficient becomes the other one. Does that make sense? Oh. Do we feel all right with factoring any sort of quadratic? All right, I think we're doing all right. There is one more type of thing that we can factor, and we call this the difference of squares types questions. So we talked about when we have 4 terms, we talked about when we had 3 terms. Sometimes when we have 2 terms in a very special type of configuration, we can apply this thing called the difference of squares formula, okay? Basically what this formula says, this is something you should probably memorize. Okay. Whenever you have something squared minus another thing squared, and A and B don't have to be specifically numbers, okay? They can be literally any sort of thing. We can kind of separate it out into a subtracted sort of factor and an added factor, okay? Now the formula I know is nice to memorize, but might not make quite sense right now. Let's do an example and see how we can apply this in real life. Okay, so we have 4n squared minus 49. Doesn't really look like something squared minus another thing squared yet, okay? So with the difference of squares formula, we've got an A and we've got a B. Anyone want to tell me what B is? B, it's not quite 49 because B is the thing that's squared to get to 49. I think I heard two things, but I didn't process, yes, what did you say? This is 7 squared, right? Okay, perfect. So we have something minus 7 squared. What is b? Ainsley? 7, right? B is the thing that is squared. Does that make sense? Okay, let's take a look at this first term here. We have 4n squared. That's not an entire thing squared, though, right? We want something big squared, right? What do you think I can write in the middle to make it be squared and get 4n squared? 2n, right? Does everyone see how 2n squared becomes 4n squared? Right, we can always distribute that square to both terms, okay? So what is a here? 2n, good. Okay, so even though it doesn't actually look like something squared minus another thing squared, if you think about it hard enough, you can actually kind of look at, okay, I have something squared minus another thing squared. Okay, so this is technically a squared minus b squared. What is the factored version? How do I? Perfect. 2n minus 7, 2n plus 7. Right? So essentially, I've taken a and stuck it in my formula. I've also taken b and stuck it in my formula. I'm left with this. Okay. Any questions on example now? If you're feeling a little shaky, I have example 10. I want you to work on this one. We also might have enough time for example 11, but the answer is on the bottom. Yes?
Well, like, just to kind of shorthand it, would we be able to use like the plus and minus sign, or would you prefer us to write it out a minus b?
So are you saying with the plus or minus sign doing like 2n plus or minus 7?
Yeah.
Normally I'd be okay with it, but this, I'd say just write off the factors, just because I feel like I would be okay with it, but if you go on to another math class, they might be like, I don't like that. So let's just write off the factors. Okay. Let's work on example 10 and 11. All right, let's go up to the front here. I've got, let's see, who did I call on to put up example 10? Was that Precious? Do you want to take us through this one? Mhm.
Since a is
Mhm.
and then
Yeah, perfect, right? So if you don't see how the 3x squared becomes 9, I always kind of just like to rewrite the first term as something squared. So I think that's how Precious got the 3x in the middle. Now 1 isn't technically squared here, but 1 squared is 1. Any questions on example 10? All right, example number 11 was that Will, right? Do you want to take us through this one?
So, A is A.
Yeah.
5B. So then it's just A.
Any questions on 11? All right, I think we actually have some time to start some new notes here. But are we all confident on factoring polynomials? Any questions so far? Okay, I think we have enough to, I think this is all you need to do the homework. So I think you should be able to do all the homework questions by now. Okay. Let me pass out a new set of guided notes. I know I'm kind of rushing things, but why don't we just talk about things and then we'll pick it up. Okay, so now we're actually going to start on the stuff that I'm supposed to be teaching for this class. I know I kind of drudged through the different tools that we use in algebra, but I think they're necessary at least. But we're actually gonna pick up on stuff that you're actually gonna see in algebra. In algebra, you're gonna see a lot of these things called equations, right? I know this is called linear equations and applied problems. I took out my applied problems because they took up a little bit too much space in my notes, so we're only gonna be talking about linear equations here. Equations, right? The EQU stands for equal, right? So whenever we see an equation, we're talking about things that are equal. And that's essentially what an equation is. It's a statement about two things that are equal. We're always going to have an equal sign when we're talking about an equation, okay? Let me just give you some notation here. Let's just say like 2x equals 1. That's an example of an equation, right? Okay, if you see something with variables and like squares, numbers that don't have an equal sign, like 2x minus 1, we call this a relation. Okay, so whenever it has an equal sign, we call it an equation. If it doesn't have an equal sign, we usually call it like a relation or something. Okay. So of course we have an equation here. Pretty easy question to start out. What do we do if I want to solve for t? Yes. Good. We divide by 2 on both sides. Some things I like to hear a lot, which I do by mistake a lot. Oh, did Ho have a question? Ah. Is your hand up, Ho? Oh, no. Maybe your hand. Okay. Ho, if you have a question, type it in the chat. I wonder if she can hear me. Oh, gosh. I think she can hear me. Okay. Well, we'll keep going. Okay, so something that I hear a lot is move the 2 over to the right side. So that's what I hear a lot of students say. I say that a lot too. I'm trying to encourage everyone to not use that sort of notation because when we deal with an equation, we're always doing something on the left and the right. We're doing the same thing on both sides. So instead of saying like move the 2 over, I encourage you to say divide by 2 on both sides. Okay. On the left-hand side, we're left with t. On the right-hand side, we are left with 3. We call 3 a solution of the equation. Okay. Sometimes we'll say 3 satisfies the equation in t. Okay. Any questions? All right. Okay, quick question. How can we check if t equals 3 is the right answer? We can plug it back in. Good, right? So I can literally take 2 times 3 and 6, and I want to check if they are equal. Well, 6 equals 6. We're good. Okay. Any questions? All right, I think I'm going to stop class here because I want to talk about equivalent stuff a little bit later.